Alright, in this lesson we're going to be talking about the midsegment of a trapezoid. Okay, a midsegment of a trapezoid is a segment whose endpoints are the midpoints of the non-parallel sides of a trapezoid. Okay, so let's say we have a trapezoid. So we know it's a trapezoid if it has one pair of parallel sides. Okay, we call those sides the bases of our trapezoid. And if we've got the two midpoints of the non-parallel sides, so the legs, the other two sides, okay, we've got our tick marks here, so that's a midpoint. Our tick marks here makes that a midpoint. And if we connect those two midpoints with a segment, then this blue segment here is a midsegment. So, what makes a midsegment special? Well, similar to a midsegment of a triangle, where we had the midsegment of a triangle was half the length of the base and it was parallel to the third side. The midsegment of a trapezoid is parallel to both bases. So now in a trapezoid we've got two sides on either side of the midsegment. It's parallel to both of them. Okay, it's also, if we look at the length of the midsegment, it's the average of the lengths of the two bases. Okay, so it's not half of either one, but it's the average of these two. So remember, to find an average, we add up. If we're taking the average of two numbers, we add up those two numbers and divide by 2. So the length of a midsegment of a trapezoid, we take base 1, we add that to base 2, and we divide that sum by 2. Okay, so the length of a midsegment of a trapezoid, base 1 plus base 2 divided by 2. Okay, let's look at some example problems and apply what we know about midsegments. Alright, example number 1. We're asked to solve for x. We've got a trapezoid here. We know that because we've got one pair of parallel sides. We've got the midsegment shown by the tick marks, so we've got midpoints. Okay, our midsegment has a length of x, and we're given the two bases, 25 and 45. Okay, so to find x, we know the length of our midsegment, so that's x equals the average of our two bases. So here's base 1, add that to base 2, and then we want to divide by 2. So that'll give us the average. So 25 and 45 makes 70. 70 divided by 2 is 35. So our midsegment has a length of 35. And if you look, remember the average is the number that's like midway in between the other two numbers. So 35 is the same distance away from 25 as it is from 45. They're both 10 points or 10 units away from each other. Okay, example number 2. We've got another trapezoid. This one's tilted up on its side. We've got one pair of parallel sides. We've got a midsegment here. So we've got the midsegment is a length of 10. So they give us a midsegment this time. Now they want us to find the length of one of the bases. So let's set up our equation again. Again, our equation, we're going to set it the same way every time. We're going to start off with the midsegment. Remember, the midsegment equals the average of the two bases. The bases are the parallel sides, so we've got x and 14. Then to find the average, we want to divide that by 2. Okay, now our x is in our fraction, so let's get rid of that fraction first. I'm going to multiply both sides by 2. Okay, so 2 is the same thing as 2 over 1. So 2 over 2 makes 1. So we're left with 2 times 10, which is 20, equals x plus 14. If we subtract 14 from both sides, then we get x equals 6. All right, let's look at 2 more examples. Okay, example number 3. Again, we're solving for x. We've got a trapezoid, we've got a midsegment, and we've got the lengths of the two bases. Okay, so let's set it up the same way. Our midsegment, so you've got to be able to identify your midsegment. Set that equal to the average of the two bases, so 8.5 plus 11.5. We want to divide that by 2. 8 and a half, 11 and a half. 8 and 11 is 19 plus 2 halves is 1, so that would be 20 over 2. 20 over 2 is 10. So I just simplified the right side of our equation. So our mid-segment 3x plus 1 equals 10, but we don't just want the mid-segment, we want to solve for x. So let's continue solving this equation for x. Subtract 1 from both sides. We've got 3x equals 9. Divide both sides by 3. What number can you multiply by 3 to get 9? X equals 3. Okay, one more example here. This time, we're given our mid-segment straight out, 39. But now this time our bases are in terms of x. But we're going to set it up the same way every time. Our mid-segment equals the average of our two bases, 3x plus 2 plus 6x minus 14, and then all of that over 2. Okay, so let's focus on the right side of our equation here. Let's simplify. So we've got 3x plus 2 and 6x minus 14. I'm going to pick out some of our like terms. We've got our x terms here. And we've got a pair of constants here. We've got a positive 2 and a negative 14, so that makes negative 12. Okay, now we got a choice to make. Now, if we were to divide both of these by 2, then I'm going to have a fraction. I'm not a big fan of fractions, so I'm going to go ahead and multiply both sides by 2. So I won't have to deal with fractions yet. Okay, so 2 over 2 is 1. 2 times 39. 2 times 40 is 80. Take away 2 is 78. So we've got 9x. Take away 12. We add 12 to both sides, then we're going to get 90 equals 9x. And what can you multiply by 9? What can you multiply by 9 to get 90? 10 it is. So x equals 10. And that is mid-segments of a trapezoid. So they are both the average of the lengths of the two bases, and they are parallel to both sides. Now, one more problem, real quick. Let's say that they give you this angle measurement was 80 degrees, and they wanted you to find x, which is this angle measurement here. Well, since we know that our mid-segment is also parallel to our both of our bases, then we've got two parallel lines cut by a transversal, and then we've got a pair of corresponding angles here. Corresponding angles of parallel lines are congruent, so then that x, or maybe we should call it y, so we don't get confused with that x, that y would have to equal 80 degrees. Okay, so look out for problems where you're looking for missing angles in a trapezoid as well.